Okay, in this video, you are going to quickly go through a quiz. So in this quiz session, I'm going to lay down a question and give you some time to answer it. I'll give you 1 to 2 minutes to respond to the question. Then I'll also, after laying down a question, then I'll quickly give the answer after laying down a question, but you should try to make it very fast and provide an answer. Question 1. So it's quiz general physics MCQ. So these are multiple choice questions. Question 1. What could be a correct expression for the speed of ocean waves? What would be a correct expression for the speed of ocean waves in terms of its wavelength lambda, the depth h of the ocean, the depth h of the ocean, the density rho of the seawater, the density rho of the seawater, and the acceleration of free fall g, and the acceleration of free fall g. A g lambda b g over h c rho g h d g over rho. So select the answer which you think is correct. So I'm giving you 1 minute. Right? So I think 1 minute is over now. The correct answer to this, the question says, what could be a correct expression for the speed of ocean waves in terms of its wavelength lambda, the depth h of the ocean, and the density rho of the seawater, and the acceleration of free fall g? So the correct answer is A. Is A. Correct answer is A. So we can compare with other answers. Remember, we said there are options. I gave you these options. The correct answer there is A. So with A, g lambda b g over h c rho g h d. Option D was g over rho. So g for A, g is meters per second squared times meters square root of. So meters squared per second squared. What do you get as your answer? You get meter per second. So this is the expression for the speed of ocean waves. So it means other answers are wrong. Right? So the correct answer there is G lambda. So moving on to question 2. Question 2. The relationship between four quantities is given by the equation P is equal to Q minus RS. Given that this equation is homogeneous, which of the following statements must be correct? A, P, Q, R, and S have all the same units. P, Q, R, and S have all the same units. All have same units. B, P, Q, R, and S are all scalar quantities. P, Q, R, and S are all scalar quantities. P, the product RS has the same units as P and Q. The product RS has the same units as P and Q. This is option C, sorry. The same units as P and Q. Then option D, product RS is numerically equal to P minus Q. Product RS is numerically equal to Q minus P. So I think 1 minute is over. Our best answer there is C. C is the correct answer because the relationship between four quantities is given by. So I told that this equation is homogeneous. P. So if it is homogeneous, units of P are equal to units of Q and units of RS. So the product RS should have the same units as Q and P, right? Because the equation is homogeneous. So our best answer then in question 2 is C. So moving on to question 3. Moving on to question 3. Question 3 says, the energy of a photon of electromagnetic radiation of frequency F is given by the expression E is equal to HF. What are the SI phase units of Planck's constant? H. What are the SI phase units of Planck's constant? H. So E is the energy. A, kg meters per second. B, kg meters squared per second. C, kg meters squared per second squared. D, kg meters squared per second cube. The answer there is B. I think 1 minute is over. The answer there is B. Right. The answer there is B. We can simply explain why the answer is B. We can explain why it answer is B. This will be said E is equal to AF. So the unit for E, want the for Planck's constant. So E is work done, which is energy is equal to work done, which is force on that is taken. This kg meters per second squared times meter, which is h. This frequency is per second. So over per second over per second. So we get our answer is kg meter squared per second, which is B. Right? Then we'll move on to question 4. Moving on to question 4. The specific heat capacity C of a particular solid. The specific heat capacity C of a particular solid at a temperature close to 0 kelvins is given by C is equal to A G cubed. Which one of the following gives the SI plus units of the constant A? So what SI plus units of the constant A? Which one of the following gives the SI plus units of constant A? That is the question. kg meter squared per second squared per B kg meter squared per second squared C meter squared per second squared per D meter squared per second squared per. So which one is the best answer there? I think the 1 minute is over. The answer there is C. The answer there is C. So we can explain how we arrived at C. It is simple to explain how we arrived at C. We said specific heat capacity is equal to AT cubed. So specific heat capacity is heat energy over mass times change in temperature. So this is in kelvins. T is in temperature in kelvins. Sorry. T is temperature in kelvins. So kg meter per second squared times meter over kg times kelvin is equal to A K cubed. So we cancel there, we get M per kelvin, which is A K to the power 3. So if you divide by K to the power 3 there, you get your A as meter squared per second squared per kelvin to the power 4. Which is the answer was C. The option was C. I'll move on to question 5. Move on to question 5. The heat capacity C the heat capacity C of a solid as a function of its temperature T is given by C is equals to alpha t plus beta t cubed. Which row in the table shows positive units of alpha and beta? So I've got A, alpha, and beta. I've got joule per Kelvin squared, B, K, joule, C, joule Kelvin, cube, D, joule per Kelvin squared, joule per. So the best answer there, 1 units for alpha and beta. So this is a homogeneous equation. So this is identical to alpha t is identical to beta t cubed. So if we work very well, this is in joule per Kelvin. So if we equate the alpha will be J per Kelvin squared. Then if we equate this joule per Kelvin to beta K cubed, remember T, this will be joule. So the answer is D. The answer to number 5 is D. Because if we divide joule per Kelvin by K cubed to get joule per Kelvin to the power minus 4, joule per Kelvin to the power minus 2 there. So the answer to number 5 is D. So I'm moving on to question 6. Right. Question 6. Let's quickly go through question 6. Which of the following will involve random errors in the measurement? Which of the following will involve random errors in the measurement? A. Not allowing for a zero error on a moving foil. Not allowing for a zero error on a moving coil 40 meter. B. Not separating background content on determine. Not separating background. Count rate. When determining the count rate. When determining the count rate from a radioactive source, from a radioactive source. C. Stopping a stopwatch at the end of the rest. Stopping a stopwatch at the end of the rest. Then option D, allow me to write option D there. Option D, using the value of GS. Using the value of GS 10 Newton per kilogram when calculating weight from a mass. When calculating weight from a mass. The question is saying which one of the following will involve random errors in the measurement. So the answer there is C. The answer is C. Stopping a stopwatch at the end of a race would involve the random errors because it would result in the values being scattered about a true value. resulting value being scattered, and not allowing for a zero error is to do eliminating a systematic error. Not separating background has nothing to do with the minimizing random errors. But stopping a stopwatch at the end of a race would result in random errors due to the variation in reaction time, and the values could be uniformly scattered according to value. G is very wrong. Using the value of G has nothing to do with random error. Now moving on to question 7. Question 7 is a bit long. Question 7. Question 7. In an experiment, the time t for a ball to fall from rest to a vertical edge was measured. In an experiment, the time t for a ball to fall from rest to a vertical distance h was measured. The given graph was plotted by a student. We knew that h is equal to half g t squared. So this is the graph that was plotted by the student. H against the t. So this is the graph which the student brought about. So which statement is an explanation for the intercept? So there was an error there when the student carried out the experiment, encountered an error, and then it resulted in the graph passing through the intercept. So what could be the explanation of the intercept? A resistance should be taken into account for larger values of h. A resistance should be taken into account for larger values of h. B, there is a constant delay between starting the time and releasing the ball. There is a constant delay in starting timer and releasing the ball. That is option B. Option C, there's an error in time. Option C, there is an error in timer which consistently makes it run fast, which consistently make it run fast. Option D, the student should have plotted h against t squared. The student should have plotted h versus t squared. So the correct answer there is B. There's a constant delay in starting a timer and releasing the ball. Because that constant delay causes the shift in the causes the values to shift in a certain direction by constant magnitude. That is why it is passing through the intercept. There's a constant delay in starting time and releasing the ball. That constant delay caused the values to be shifted in one direction. So that is the reason for the error there, for the intercept in the graph. Now moving on to question 8. Question 8. So there are only 10 questions. So question 8. Which one of the following techniques should reduce or eliminate the systematic error of the quantity being measured? Question 8. Which one of the following techniques could choose or eliminate the systematic error of the quantity being measured. Adjusting an ammeter to remove this zero error before measuring current. Adjusting an ammeter to remove its zero error before measuring a current. B, option B, measuring several intermodal distances on a standing wave to find the mean intermodal distance. Measuring several intermodal distances, IM intermodal distances on a standing wave, SW, on a standing wave to find the mean, intermodal distance, IM. C, measuring the diameter of a wire repeated and calculating the average. C, allow me to write option C there. C, measuring the diameter of a wire repeated, measuring the diameter of a wire repeatedly and calculating the average. And calculating the average. D, timing a large number of oscillations to find the period. Timing a large number of oscillations to find a period. So here the question says which one of the following technique is to reduce or eliminate the systematic error. So the answer there is A. Right? Adjusting an ammeter to remove its zero error before measuring eliminates the systematic error. B has to do with eliminating the random error. C has to do with eliminating the random error, measuring the diameter of a wire repeatedly and calculating the distribution. D has nothing to do with eliminating the systematic error. Now we'll move on to question 9. So question 9, I will simply detect question 9 and we simply go to the options. Then allow me to detect question 9 and simply I will detect it, then we quickly move on to options. Question 9 says, in an experiment to measure the acceleration of free fall, each of the 4 students made a series of measurements. The results are as shown in the given table. In an experiment to measure the acceleration of free fall, G, each of the 4 students made a series of measurements. The results are as shown in the table. So the results are A, 9,81, 9,79, 9,84, 9,83. B, 9,81, 10,12, 9,89, 8,94. Students C got the following sets of reading: 9,45, 9,21, 8,99, 8,76. Then finally student D got 8,45, 8,46, 8,50, 8,41. So In an experiment to measure the acceleration of wave for a king, each of the four students made a series of measurements. The results are shown in the given table. So these are the results. Which of the students obtained results that could be considered precise but not accurate? Which of the results here are precise but not accurate? Which of the sets of results are precise but not accurate? You know that the correct value of G is 9,81. So which one of the following results? So the answer there is D. These results are precise if we measure the mean value. It is far from 9,81. But these values are close to each other, so they are high precision. So lastly, we're going to move on to question 10. So in question 10, I'll simply detect the question and I'll give you options. Question 10. The true value of a quantity x is x naught. In an experiment, the quantity is measured many times and the value n of it is giving a value x is plotted against. Each of the following graphs gives measurements that are precise but not accurate. So this is measured many times. So the value n, so this is the true value. So we're told the number n of the readings giving a value x is plotted against the x. So this is x. So which of the following graphs best shows measurements that are precise but not accurate? So B, so N, this is the true value, x naught, example. Then option C. Option C, and this is the true value. Then option D. So the question says, which of the following graphs best shows measurements that are precise but not accurate? The best answer there is B. You see? So this, the mean value is far from the true value, so it's not accurate. But the values themselves are closer to each other. So this shows the results that are precise but not accurate. So kindly mark for yourself to see how much correct answers you got out of 10. So in our next lesson, we're going to look at the treatment of